Section 3.2 is zeros of polynomial functions. And as we take a look at this section, there's going to be a big portion of the section that relies on being able to do synthetic division. So I'm not asking you to remember right now. I'm just wanting to know so that I kind of know where we are at. How many of you have done synthetic division at some point in the past? Like, you know kind of what I mean when I say it. Okay. So we're at about maybe 75%. That's not bad. So I'll go through it in detailed form, of course, but just to give you a heads up, that's where the majority of this lesson lies, is in synthetic division. All right, so to start with, we're going to take a look at a couple of theorems, the remainder theorem and the factor theorem. All right, so the remainder theorem says that when a polynomial is divided by a monomial, x minus c, then the remainder is p of c. This talks about how to divide polynomials. And then the factor theorem is basically a specialized case of the remainder theorem. It says if that item that you actually divided by happens to end up being a factor, right? That's a very specialized case. It doesn't always happen. But if it happens to be a factor, then that happens if and only if it's actually, the value c is actually a zero of the function, or if p of c equals 0. All right, you guys ready to try an example? Sorry, I see a couple people still writing. I'll pause. There's one more slide with significant writing later in the lesson, and then that's it. So. Okay, let's try an example. So this talks about synthetic division, so we'll kind of start from there. And it says to use synthetic division to find the quotient and the remainder when, and it gives you a polynomial, is divided by one of these linear monomials that we talked about. Or binomials, not monomials, binomials, excuse me. All right, so here's how we start the process. You take the term you're dividing by, x minus 4. And in essence, what you're doing is you're saying x minus 4 equals 0, and you're solving for x. So this is x equal 4. We're all good with that so far, right? X is 4. You're going to use that number 4 as the divisor in your synthetic division. So write your 4 down and put it sort of in a box like that. Structurally, to set this up, next to the 4, we're going to create 3 columns. An x squared column, an x column, and a number column. You don't really need to write the x squared x and the number down unless it's something that's useful to you. If it is, that's wonderful. I'll keep writing it throughout this lesson, but they aren't necessarily, required to be there or anything like that. What is needed is the coefficient in each of those places. For example, what's the coefficient in front of x squared? 1. So I'm going to put a 1 next to my 4 like this. What's the coefficient in front of x? Yep, and the coefficient at the end, or the number by itself, the 9. Okay, so what you need to for sure have set up in your synthetic division is this, that row right there, okay? I'll show you why I put the x squared x number stuff up there in a minute. All right, our next step is to draw sort of a line, oops, let me get the black back out, the line down here. Kind of like, when you do addition, old school style, like first grade, where they do 5 plus 3 and put the line underneath it. It's like that. The first step is to bring the 1 down and rewrite it. Easy first step, right? The next step is to take the result, whatever you pulled down, in this case of 1, and multiply it by the number that's in the box. So what's 1 times 4? 4. And you'll put that result right here of 4. And then you're going to add down. Every time you go down in one of these rows, you're adding, okay? It's addition. So negative 3 plus 4 is 1. And then 1, again, times the 4 that was on the outside would be 4. And then, again, adding down, 9 plus 4 is 13. I'm going to put a box around the 13 like this because it's separate from the 1 and the 1. So let's actually see what happened here. This number right here is the remainder. The values right here are the coefficient values for the quotient. So what do I mean? Well, your problem started out as x squared, x, and a constant. But then we divided it by x minus 4, which means the power of the x's went down. We divided x squared by x, essentially. So what we're left with is an x column and a number column. It decreases the power by 1, okay? So an x column and a number column, so these are the coefficients that go in front of each of these values. Not that number is a value, but you know what I mean. So this is 1x, or just x, plus 1. That's what's left. And this is called the quotient. Now, I want to show you something. This is not emphasized in your book, but I want to show you why we're using synthetic division as opposed to one other possibility. There's another possibility in what we're doing is that we could be using what's called long division, and there's nothing wrong with long division. The reason we typically like the synthetic division better is because it's faster. And oftentimes, you know, we think faster means better, don't we? It means more efficient anyway. We can get it done quicker. But if this were actually being done with long division, it would look something like this. The x minus 4 is what we're dividing by. We are dividing an x squared minus 3x plus 9. And if I were to go step by step, I would ask myself questions something like this. What do I need to multiply x by to get x squared? And the answer would be x. And you'd have to write this x down here, and then you'd multiply the x on top times the x minus 4 on the outside. Like this looks like long division with just numbers. So this would be x squared minus 4x. And then what you would do in long division is you would subtract that quantity from what you started with. Well, subtraction would mean subtracting both pieces or changing the signs. These x squareds would cancel. You'd have negative 3x and positive 4x, which would leave you with x plus 9. And you'd ask yourself the same question. What do I need to multiply x by to get x? And the answer would be 1. So you'd put a 1 up here plus the 1, and you'd have x minus 4. And then you would change the signs, and you would end up with a remainder of 13. Those are all the same pieces, but done in a very different way. In some fashion, this is nicer because it feels more like the division you learned back in 3rd and 4th grade. It really does. It looks much more like that. The nice thing about synthetic division is that I don't have to deal with any of the x's in the problem. They're all just sort of hidden, right? I'm just looking at the coefficients. All I'm working with are the numbers in the problem. And I end up with the same answer. I have a remainder of 13 right here, and I have the quotient of x plus 1. Now, thinking about this, there is a way to make sure that you have the right answer besides doing the problem twice and doing all of this. I don't want to do the problem twice. Do you? Not really. You can actually make sure that you have the right remainder by doing something else. So this will actually answer for us, did I find the right remainder? And if I found the right remainder, I probably found the right quotient in the process, okay? So how can you find out if you have the right remainder? Well, over here, this says that dividing by x minus c is the remainder of finding p of c. In other words, instead of actually going through the division process, I'll get the same remainder if I simply plug the number into the equation. So take a look over here. If I took the value 4, right, this is my value 4, and I found 4 squared minus 3 times 4 plus 9. Grab a calculator or just numerically calculate this quick in your head if you want to with arithmetic, whatever. Tell me what you get. What is 4 squared minus 3 times 4 plus 9? It's 13. And that's not an accident. That will always happen. If you've done the process or both processes right, this will always match this. So it's a real quick check step that you can do just to make sure you didn't make an error along the way. Now, unfortunately, that doesn't tell you what the quotient is, right? It only tells you what the remainder is. So you can't use this piece in lieu of doing the other one. It doesn't give you all the same information, but it confirms that the first time that we did it with synthetic division, we did it right. Does that sound good? Okay, we're going to do another example with synthetic division. This one simply asks us to find f of negative 1. So we'll be able to confirm that we've done it right at the end by calculating f of negative 1, right? Just plugging the negative 1 in, we can confirm that at the end. But the directions do say to use synthetic division, right? Now I had a student in my first class this morning ask me, well, what if I just do it the other way? And I said, well, if you do it the other way on my math lab's not going to know. I mean, they're not going to know whether you did it right or not. However, you'll probably be shortcutting yourself because I will know if I grade your work whether or not you've done it with the right way that it's mentioned. On this particular problem, it says use synthetic division, and so that's what I would be expecting to see if I were grading a quiz or a test, okay? So I would encourage you to practice the problems the way they ask you to in my math lab, just to make sure you get the practice you need before your test, okay? So let's take a look at what they're wanting us to do. This value is the value that goes outside in the box, okay? And then I've got columns for the same values from the problem. I've got x cubed, x squared, x, and the number column. And this problem is a really good example of why I like to write out those headers, at least for a time being, until I get comfortable with it or until you get comfortable with it. Because what do you notice happens in this particular polynomial? It's missing an x term, right? So it would be really easy to go in here and just simply write down 1, -4, and 8. And there's a problem with that, right? You're missing the 0 in the x column. So if I keep these lined up, I'm less likely to miss that 0 placeholder. All right, so let's try it. We're going to bring the 1 down. And I'm multiplying every time now in my box by -1. -1 is a very nice number to multiply by because all I have to do is to change the sign that I have, right? So this is a 1, so now I have -1. -4 minus 1 is -5. -5 times -1 would be 5. 0 plus 5 is 5. And then -1 times 5. Lots of 5s here, -5. And then my last number, which goes in the box over here, 8 minus 5 is 3. This, the remainder, is the answer to the question. The question wanted me to find f of -1. And that f of -1 is 3. So what do you have to show, you know, in terms of like, if you were doing this particular problem on your homework or something and you were writing it up for me to actually grade? This right here is what you would need to show, okay? Just exactly what's written here. The piece I'm about to show you right here is a check step. Nobody has to do this check step. It's totally your choice. I would encourage you to do it because it doesn't take very long and it confirms to you that you did the problem right. All you're doing is you're plugging -1 in for all your x's. So you have -1 cubed minus 4 times -1 squared plus 8. So calculate real quick and let's make sure. Do we really get 3? Kara says yes. I've got a few nods. Does that work out? Good deal. This gives me the same 3, so it checks out. I did the problem right. Is that good? All right, the next one is a slightly different directions. It asks us if -1 is a 0. So jot down that question first, and then we're going to go back to where we actually wrote down those 2 theorems and examine what it's really asking me for. everyone have it written down? All right. Back over here, it talked about zeros in the second theorem, the factor theorem. It said x minus c is a factor of the polynomial if and only if c is a 0. C being a 0 means that if I plugged the value c in, the remainder would be 0. And that's exactly what we mean when we talk about something being a factor of another number. Why is 2 a factor of 22? Well, because when you divide it, it goes in evenly. There's no remainder, right? The same is true here. If I have a remainder of 0, then it went in evenly. Hence, it was a factor. So that phrase factor and that word factor and that word 0 are interchangeable in respect to the number being a 0 and the binomial being a factor. Those are the same expression. So if you're taking a look over here, this question is asking you, is w of negative 1 equal to 0? That's what it's really asking. Is it a 0? And one way you can do this, especially this one doesn't actually tell you you have to use synthetic division. We're going to for practice on this, but this one doesn't say you have to. You could just plug in negative 1, right? Let's do it real quick. Let's just plug in negative 1 and see what happens. If I do w of negative 1, what do I get? Double check, there's lots of negatives going on in this problem. They're all over the place. It's 0. So this does in fact equal 0, so the answer is yes. It is a 0. I mean, that's really the answer to the question. What I just wrote down right there is one way to show support or work for it because they didn't tell you how you had to, right? If you're not told how you have to do a problem, then you have some options in it. So what if we use synthetic division? What would that look like? What if it said use synthetic division to decide if this is a 0? I could ask that, right? It's a very similar question to the last one we looked at. Well, how would we do it? We'd do it the same way we did the last problem. You put the negative 1 in the box on the outside, and then you'd have your columns for x cubed, x squared, x, and your number. This is 3, 2, negative 2, and negative 1. Like this is running into all my stuff. All right. So then, what do I do first? Well, first I'll draw my line. What do I do next? Drop down the 3. It comes straight down. Then what? Multiply by the negative 1. There's several negative 1s in this lesson. I don't know what I was thinking when I did my notes exactly, but apparently I liked the number negative 1. So here's a negative 3 for you. 2 plus negative 3. Negative 1. We have a positive 1 then next. And then we get a negative 1. And then a positive 1. And then what happens? We get 0. And we expected that, of course, because we kind of did the shortcut method first, right? The 2 different ways of doing it. So we're not surprised that that's 0, but it will be 0 if it really is a factor. So what does it mean to be a factor? Well, what it really means is that the result of this, right, this actually was x equal to negative 1. And if I were to move that to the other side, this is the same thing as saying x plus 1 equals 0. Is everybody good with that? Just add plus 1 to both sides. What this means is that if I took x plus 1 as a factor, and I took the quotient right here, remember it's 1 degree less, so this is not 3x cubed, it's 3x squared, minus x minus 1, that this would be a way of factoring the original w of x equation. It would factor perfectly like that because there's no remainder at the end, right? That's what that means. It's the same thing as saying why does, I used 22 as an example before, why does 22 factor by 2? Well, because 2 times 11, right? Because I can rewrite it as 2 times 11 and there's no remainder, right? It's the same thing, it's just with a polynomial instead of a number. Okay? Ready for another one? Of course you are. Smile. Okay, let's do another one. I got enough battery, I can walk around now. Okay, question is x plus 5 a factor? Well, we just discussed a minute ago that being a factor, right, like x plus 1 here, means that I can put that negative 1 in that little box on the outside and do the synthetic division, and I end up getting 0 at the end. It's the same question. So I can do that over here too. Just like I did the x plus 1 on the other one, this x plus 5 equals 0. That doesn't look like a very good 5, but pretend for a moment with me. If I move the 5, this is the same as x equal to negative 5, right? This is x equal to negative 5. It means that that negative 5 is the number in the box. I'm starting with x cubed, so I'll have columns for x cubed, x squared, x, and 8. All right, what numbers go across the top then next to that negative 5? Okay, is everybody good with that? Oh, that shouldn't have said 8. I should have put a number there. No wonder that looks funny. Here. Number. Here we go. Silly, silly, silly. All right, and then I'm going to draw my line. I'm going to pause for like 15 seconds, and I want you, maybe it'll be a little longer than that. Finish this, and let's make sure we all get the same thing. Okay, so try it on your own. Do the synthetic division. Okay, so you should have brought down a 1. Did everybody do that? Just nod your head. Yeah, okay, good. 1 times negative 5, did you get a negative 5 here? Excellent. 8 minus 5 would be 3. You did 3 times negative 5 is negative 15. All looking good so far? Awesome. And then there's a negative 4. And then the negative 4 times the negative 5 gives me a positive 20 for a remainder of 0. Did you guys get that? Okay. So the question was, is it a factor? The answer is yes. What if you actually made a mistake somewhere along the way on this one, or maybe it was a different problem, and this number here at the end said 3? What would your answer then be? No. The answer would be no. So make sure that your answer matches your work, because if you make a mistake somewhere along the way, I'm going to be making sure that your answer and your work make sense together. Okay? So the answer to this question is yes, it's a factor. Okay, so just like I did before, what we want to do then is we want to write those two pieces, the binomial that I originally divided by, x plus 5, and the quotient that I got next to it. So again, this is the x squared column now, the x column, and the number column. So what polynomial is represented by the 1, 3, negative 4 that I get for the other part of the answer of this particular synthetic division problem? What's the polynomial? X squared plus 3x and minus 4. All right, so that's factored, but it's not yet factored completely because this piece is a what kind of a polynomial? It's a trinomial, but it's also quadratic, right? And you have methods to be able to work with quadratics. That's something we spent a considerable amount of time in a couple of different sections at this point on working with. If it factors, we all say, yay, because that's the easiest way, right? And if it doesn't, what would we do next? Probably the quadratic formula. Does this one factor? Yes, it does. All right, fantastic. So we all said yay, right? All right, so here's the x plus 5. Don't forget it. It is part of the problem. And this one will have two sets of parentheses. How does x squared plus 3x minus 4 factor? All right, 4 and 1. It's a positive 4 and a negative 1. That'll give me the positive 3 on the inside. Now you have to be careful. It says to factor completely. That's one part. So we have done the factor completely. What's the other part of the directions then? Final zeros. So final zeros means to take those factors and set them equal to 0. So what I really need then is I need x plus 5 times x plus 4 times x minus 1 to equal 0. And how do I find where that whole thing equals 0? Like, what's the next thing I do? Right, I set each part equal to 0. Now, the first one we already did, kind of, because that's where the problem began. But the other two are new. X plus 4 equals 0, and x minus 1 equals 0. So this one would be the negative 5 we expected. What do we get from the x plus 4? Negative 4. And then the x plus 1? 1. So there's two answers to this part of the question, right? The factoring completely, which we did that, and then the solving, setting it equal to 0, finding the actual zeros through the whole problem. All right, here's my other slide. There is a typo on this slide. I have fixed it, so this is a ton of writing. I know, I'm sorry. There's a P here and there's a Q here, and those are on purpose because I had a typo when I originally did the slide up. Okay. The fundamental theorem of algebra says that if you have a non-constant polynomial, so you don't have just like f of x equals 3, okay, that's a constant polynomial, so you have anything that's variable in it, then you'll have at least one 0, guaranteed. So that's kind of cool to know. We're always going to be able to set it equal to 0 and find some solution. The rational zeros theorem is like the wordiest thing to actually do the process. It's super not friendly in terms of its structure. But it says that if you have a polynomial function with integer coefficients, which is like always the kinds we deal with pretty much, that all possible rational zeros of p of x have the form p over q. This is little p, where the little p is a factor of the constant term and the little q is a factor of the leading coefficient. So write all that down and then we'll pick back up. Okay, is there anyone still writing? A couple people. Okay. Okay. Think about the last problem we did. It started out as a cubic equation, right? And the only reason we really were able to start the problem and factor was because they sort of gave us one of the factors to start with, right? They told us x plus 5 is a factor. Well, they didn't exactly tell us. They sort of asked us, but it was like a leading question, right? They asked us so that we could get to the point where we could factor it. So what if they hadn't? What if there had not been the x plus 5 given to us at the beginning? Well, then the problem would look an awful lot like this one. They don't tell us what we are going to do. We have to figure it out. We have to figure out what number will we possibly be able to use synthetic division with and make it work. Well, on this one, we're not going to actually find the zeros. We're just going to list all of them that are possible from that really long definition thing that you just wrote down, that theorem. All of them that are possible. So how do we do that? Well, what it talked about in that theorem is looking at the factors of the first coefficient, the leading coefficient, and the factors of the last coefficient, the constant term. So what are the factors of 8? Start with 1. 1, 2, 4, and 8. And you'll notice these all occur in pairs, like, right? 1 and 8, 2 and 4. That always happens. Factors occur in pairs. What about the coefficient 15 at the end? What are the factors of 15?
1, 5, 3, 15.
Yep, 1, 3, 5, 15. Okay? So these are the p-values, and these are the q-values that are referenced on this theorem. So what does it say I do? Well, it says I divide every p-value by every q-value. So my p over my q, and if I took the first p-value, it's 1. And I'm going to take the number 1 over here in the p column over here, and I'm going to divide it by all 4 of the numbers over here that are q's. So I'm going to have 1 divided by 1, and 1 divided by 2, and 1 divided by 4, and 1 divided by 8. There are 4 different possibilities. But really there are 8. Because what I really didn't write was the plus or minus. But that's not all of the values that are p, right? P also could be 3 over 1, 3 over 2, 3 over 4, or 3 over 8. Or maybe it's not. Maybe it's the 5s. Maybe it's 5 over 1, or 5 over 2, 5 over 4, or 5 over 8. Or perhaps 15 over 1, 15 over 2, 15 over 4, and 15 over 8. Okay, so this theorem over here says if there is a real 0, and there doesn't have to be any real zeros, there have to be zeros, but they don't necessarily have to be real. They could be complex, right? Like imaginary numbers, we've dealt with some of that before. But if there are any real zeros, they got to look like this. Any rational zeros, excuse me, they got to look like this. They got to have this form. How many of them do we have on the board? 16, but then it's plus or minus at the beginning, which means there are 32. And I don't know about you, but doing 32 synthetic divisions to figure out if any of these even work doesn't really sound like a good use of my time. Agreed? Yeah. Okay, so if we didn't have any other tools at our disposal, we would kind of be relegated to doing that. We'd try to make an educated guess as to which one we think it might be, and we would go with that. I mean, like that's what we'd have to do. But fortunately for us, many of you probably have graphing calculators, or you have access to some kind of a graphing utility like it's within a computer. So as you're doing your homework or whatever. This is probably, at least to this point, the only section of material where you really have a distinct advantage by having a graphing calculator with you. So I would encourage you when you come to do the test, and I'll remind you when we get to the test because it's still a couple weeks away, that you have a graphing calculator. Borrow from somebody down the hall or something. It will help you on this particular type of question. So I'm going to show you what you can use your graphing calculator to do as we do this next example. This one actually asks us to find the zeros. This one just said, oops, hang on. This one just said to list all the possible ones, right? It didn't actually ask us to find them. It just said to list them all that are possible. Kind of trying to show you that this is kind of a messy process. Well, it's not always that messy. I mean, the coefficient here is a 1, and what are the factors of 1? You know, just 1, right? It's not real exciting. Over here, this is a 2. What are the factors of 2? 1 and 2, also not very exciting. So if you're looking at p's over q's here, you don't have a lot going on, right? You've got this 1 divided by this 1, now that sounds an awful lot like 1, and you've got the 2 divided by the 1, which is an awful lot like 2. There are how many possible zeros here? There are really only 4. Now, if you had to do 4 synthetic divisions to figure out which one it was, that would not be the worst case scenario, right? You could do 4. I'm not asking you to do 32, but you could do 4 if you had to. But I'll show you how your calculator can be more helpful, if you have one, to deciding which of the 4 to try first. That's what we're going to do. We're going to use our calculator to help us make decisions. All right, so I'm going to turn on this document camera in theory. Even in reality, look at that. And what you're going to do, if you have a calculator, follow with me. If you don't, and you have this later, listen back to the video, and you can go follow the directions, or come see me in my office. Go to the Help Center. They're great at using calculators for stuff because we use them more and more as we get further in math. What I want you to do is to hit y equals, if you aren't already here, hit y equals to bring you to the screen. And you're going to put the equation in that's on this particular problem. So this is x to the third minus x squared plus 2. And you're going to graph. Just so that we're all in the same graphing window, if you'll hit zoom 6, that'll put you in a standard 10 by 10 window, the negative 10 to 10s. So you have a calculator, you graph it looks something like this. What you're interested in looking at on this particular graph is the place where it crosses the x-axis. And which of my 4 values does it look like it probably crosses the x-axis at?
-2.
I think it's at -1.
-1.
I think it's at -1 because each of those little hash marks is 1 unit, so I think it's -1. Is everybody good so far? We're looking at the zeros, the x-intercepts, the places it crosses the x-axis. Okay, so we're going to do synthetic division with the number -1. So back on your paper, we're going to use the -1 on the outside of the synthetic division. And we've got our x cubed, x squared. Don't forget about x because there's no coefficient x on this one, right? It's a 0 and the number. So I have 1, -1, 0, and 2. All right, so synthetic division, almost old hat by now. We've done it several times. We bring the 1 down. I told you I liked -1s today, right? Okay, 1 times the -1 on the outside would be -1. -1 plus -1 is -2. -2 times -1 would be +2. 0 plus 2 is 2. And then 2 times -1 is -2. And it's a 0, and we're not at all surprised. Because that's what it looked like on the graph, right? That's an expected result here. But what does it mean? Well, what it means is that this piece right here, which was x equals, hang on, let me back up just a sec. X equals -1. And if I added the 1 to both sides, right, this means I've got a factor of x plus 1. In here in the middle, right here, the quotient means I have a 1x squared minus 2x plus 2 as my second factor. Now, the directions don't exactly ask me to factor, but the factoring is part of the process in order to find the zeros. So this one, we would then hope factors. And if we hope too hard, our hopes will be dashed because it doesn't factor. So what are we going to do instead? Y'all told me before, quadratic formula. We're going to have to do the quadratic formula for this one. So with the quadratic formula, we've got x equals -b. Well, the b value is -2, so that's +2. Plus or minus the square root of b squared. That's -2 squared. Minus 4 times a is 1, and c is 2. Over 2 times a, which is 1. 2 plus or minus. All right, so -2 squared is 4, and then 4 times 1 times 2 would be the 8. So this is 4 minus 8, so I have -4 underneath the radical. All right, what's the square root of -4? 2i. So I have 2 plus or minus 2i over 2, which gives me a final answer of what? 1 first, and then plus or minus I. Right? The 2's are going to, they're going to factor, or they're going to cancel out, but they all cancel out to 1's. Okay? So the answer, or the question actually asked us to find all zeros that are real and complex. So our zeros are -1, 1 plus I, and 1 minus I. Thumbs up. It's all right. Okay, we have one more example. It's very similar to this one, same directions, in fact. Find all real and complex zeros. But take a look at the leading coefficient and the constant term at the end. 15. We already did that, right? 1, 3, 5, and 15. 14. What are the factors of 14? 1, 2, 7, and 14. So when we had this situation before, they weren't these exact numbers, and I had 4 in each case. We had 32 possibilities, right? And we all decided probably doing 32 synthetic divisions was not in our best interest. So we're going to use our calculator to help us out to decide which of those 32 is the best one to try. So grab a calculator if you have it and put this equation into y1. So I have 15x to the third minus 37x squared plus 44x minus 14. And I'm going to zoom 6. It looks like a fraction. You're right, Ansley. It's exactly what it looks like. Something between 0 and 1, it appears, right? Okay, so we could sort of guess. Probably not the best use of time either. So I'd like to show you a trick with your calculator to figure out where it's actually really crossing. And it's not trace, because trace won't find it exactly for you either. But there is a really cool menu here that says calc. Do you see that? Calc does not mean calculator, and it doesn't mean calculus. It means calculate. It's going to calculate some things. So we're going to get that button right there by hitting the second button first, second, and then trace. And it'll bring up this calculate menu. And what we're doing in this section is finding zeros. So option number 2 says 0. That's the one we want. Okay? Now it's going to give you a question on your screen. It says left bound. And then after I hit a number here, it's going to ask me right bound. All it needs is a number to the left of where it's crossing and a number to the right of where it's crossing. So we think that it looks like it's crossing at maybe about 1/2. I mean, something like that, right? So any number before 1/2, like maybe 0 or maybe -5, I don't care what it really is. But you need to put in a number that comes on this side, the left-hand side. So I'm going to put in 0. And then it says right bound. I need a number on the right-hand side of the graph that comes after where it's crossed the axis. What do you want to put in? 1. And then it's going to say guess, and guess doesn't really matter. You just need to pick a number between 0 and 1. Okay, just anything between 0 and 1 will be fine. So I'm going to go with 0.5. And it's going to tell me here at the end that there's my 0. You see the x value? It says 0.4 with a bunch of 6's. Now, if I didn't have the 4, I would know what that number is as a fraction, right? 0.6 repeating, I know that fractional number. It's one I see often. I don't know this one. So I want to use a calculator to actually figure out what that fraction is supposed to be. So if you go back into the regular screen in this calculator, I'm going to calculate this and I'm going to trick it. Okay, so I'm going to put 4 and I'm just going to put a whole bunch of 6's. Look at that, lots of 6's. And I'm going to hit enter. And the calculator thinks that that number is now stored in the calculator. This button right here that says math has a button at the very top that turns things back into fractions. This is the fraction, which is actually very close to the value of 1/2, or 0.464, and then the 6 repeating. 7/15. That is where it crosses the x-axis. So, real quick, let's do the synthetic division, and then I'll let you guys finish up the video for this later for this number, because I want to show you that the synthetic division for the fractions don't necessarily have to be awful, okay? So 7/15 is my number on the outside, and I've got all the coefficients. 15, -37, 44, and -14. The 15 comes down. And it's super friendly to multiply by 7/15, because what happens when we multiply them? We get a 7. -30 and 7 add together very nicely to give me -30, which is also a nice number to multiply by 7/15. Because the 15 in the denominator and the 30 will reduce to giving me a -2 times the 7 on top, -14. What's 44 minus 14? 30. Again, 30 is so very nice because it multiplies by the 7/15 now to give me a positive 14, and as expected, I get a remainder of 0. Not only that, this will take me just a second, 15x squared minus 30x plus 30. If I were to look at this and set this equal to 0, What do you notice about the coefficients there? They have something in common, right? 15. And if I factor out the 15, I have x squared minus 2x plus 2 left. I also, from up here, already have one of the zeros, right? X is equal to 7 over 15. That's one of my zeros. The other thing is, do you recognize this? It's the same one we did over here, right? It's the same one we did over here. So the other two zeros are 1 plus I and 1 minus I. So my three x values here are 7/15, 1 plus I, and 1 minus I.